Hi, I'm Vance, and welcome to Repair and Replace. If your refrigerator is too cold, or it's freezing some of the food, then it could be one of several problems. To cool the fridge compartment, cold air from the freezer is circulated through a vent. Food that is too close to the vent might freeze, so make sure that there's enough space for air to circulate. As well, it can be best to adjust your fridge settings, but always wait 24 hours after a change. Then you can verify the temperature with a thermometer. The fridge should sit between 2 and 5 degrees Celsius, or 38 to 42 degrees Fahrenheit. If it's still too cold at the warmest setting, then it could be a problem with the cold control thermostat. In models that use a control board, a faulty sensor can also create temperature issues. In this episode, first, we'll learn how it all works. Then we'll test each component with a multimeter. This applies to most top freezer, bottom freezer, and side-by-side refrigerators. All refrigerators work in the same basic way. When cooling is needed, the cold control sends power to the cooling circuit. The compressor pushes the refrigerant through the system. In the freezer, heat is extracted by the evaporator coils and is released through the condenser coils behind the refrigerator. This process continues until the set temperature is reached. Cold air from the freezer is circulated into the fridge through a small vent. Without proper spacing, there might be a cold spot near the vent. The refrigerator will run longer to cool the entire system. The damper controls the amount of air that is circulated into the fridge. This is often controlled by adjusting a slider in the freezer. Models with a control board will have a damper motor. If the motor fails, then the damper might stay open, letting too much cold air into the fridge. Alternatively, if the thermistor is faulty, it'll misread the temperature and the system will overcompensate. Models that have physical dials use a cold control thermostat. A faulty thermostat can cause the compressor to run more often. Using a multimeter, components can be tested for continuity. A continuity test will determine if there's a continuous path for electricity to flow through. Without continuity, the component will not work and will need to be replaced. To begin, you might need a screwdriver or nut driver and a multimeter. Keep in mind there is some variation between models, and not all refrigerators will have the same parts. You can enter your model number on the AMRE Supply website to see a parts breakdown. This can be helpful to show you which parts are in your refrigerator and where they are located. First, slide the refrigerator out from the wall. When there is enough room, unplug the cord to disconnect the power. In this case, you can work on the refrigerator in place with it still against the wall. Some models use a cold control thermostat, which will be near the top of the fridge compartment. These have a physical dial instead of buttons. Remove the screws and lower the control housing. It might be held in by plastic tabs, so don't force it or it might break. In some cases, you can disconnect the wires and remove the entire housing. Depending on the model, you might have to remove the dial first. Now lift up and disconnect the wires. Next, remove the thermostat and the sensing bulb. Set the multimeter to the ohms or resistance setting. With the dial turned to any cold setting, test between both terminals. You should get a continuity reading between 0 and 1 ohm at room temperature. You can test to see if the contacts are stuck closed. Set the thermostat to the warmest setting and place it in a working freezer. After 30 minutes, remove it and test. There should be no continuity and no reading on the multimeter. If it fails the test, then the thermostat is faulty and will need to be replaced. Take the new thermostat and align it into the housing. Now push the sensing bulb into the mount. Next, reconnect the wires. Now push the dial back into place. Align the control housing and reconnect the wire harness. Now tighten the mounting screws. Some models use a sensor and a control board to regulate cooling. The temperature sensor is a heat-sensitive resistor, also known as a thermistor. As the temperature changes, so does the resistance. The control board monitors the resistance to determine the temperature. To test the sensor, it can be helpful to use a resistance chart, which is sometimes printed on the tech sheet. The tech sheet is normally behind the kick plate. It also might be mounted at the back or will be hidden under one of the top hinge covers. In many cases, the sensor can be accessed by removing a small cover. Disconnect the sensor wires and remove it. Now set the multimeter to the ohms or resistance setting. Next, touch the probes to each terminal. At room temperature, we're getting a resistance of 2600 ohms, which is close to the rated value. For accuracy, it's best to take another measurement to compare. Test in a glass of ice water with a temperature of 0 degrees Celsius or 32 degrees Fahrenheit. As the thermistor cools over several minutes, the resistance should now be close to the second value. If either test differs more than 10% from the rated value, or if there is no resistance and no continuity, then the sensor is faulty and should be replaced. Push the sensor into the bracket and reconnect the wires. Align the cover. Now tighten the mounting screw. If you have a side-by-side or bottom freezer model, then you might have an air damper motor that controls the airflow. First, unscrew the plastic housing and remove it. Now disconnect the wires. Next, remove the damper motor. Now test the motor for resistance. There should be a reading of around 1000 to 10,000 ohms. If the reading is significantly off, or if there's no resistance and no continuity, then the motor is faulty and should be replaced. Some motors can't be tested this way. If the resistance is more than 1 million ohms, then the motor likely has sealed internal components. This means you won't be able to test the resistance of the motor windings. If you're not sure if it's faulty, then it's still best to replace it. Align the new motor assembly and snap it into place. Now reconnect the wires. Align the housing and tighten the screws. Now replace the cover. If you have eliminated all other problems and the refrigerator is still not working properly, then it could be a problem with the control board. The board is often located near the back or in a small box behind the kick plate. First, do a visual inspection of the board. If you see any charred or blackened spots, then it's a good sign that there's a failed component or short circuit in the board. As well, double check that all the wire connectors are secure. A loose connection might prevent components from receiving power. In many cases, it's best to install a new control board. You can see more in the video linked below. Plug in the cord to reconnect the power. Now slide it back into place. Make sure to leave a couple of inches of space between the refrigerator and the wall. This will allow for proper airflow. Now test the refrigerator to see if it's working properly. If you like this and want to see more tutorials and informational videos, then subscribe to our channel. And if you need help, you can call or visit an AMRE location to talk with our knowledgeable staff. Thanks for watching.